Start talking combinations today. And we talked about combinations at the very beginning of this unit briefly when I talked a little bit about fruit salad versus the fruit platter. Do you guys remember that? Yeah. And the fruit salad was the example of the combination. Fruit platter was the example of the permutation. Does anyone remember what the distinction was between the two? What's the difference? Well, you're doing this with your hands. That's important. Yep. Yeah. Good. The fruit platter has a specific order. Each color fruit, in my case, is going to a specific place on the platter. Whereas in a fruit salad, everything's going into the same bowl, you stir it up. It doesn't really matter if you put the red fruit in first and then the green fruit and then yellow fruit. You're mixing it all up into one kind of combination and it's all going into one, so order isn't important, okay? And that's the main distinction between a combination and a permutation, okay? A permutation is not really an arrangement, it's a grouping, okay? So a combination is a grouping where the order of the objects in the group doesn't matter. Okay, so let's take the example of the letters A, B, and C. Okay. How many ways can I arrange them? How many permutations are there of those letters? How many ways can you arrange 3 letters? Yeah, some of you are holding out your hands. Yeah? 6 of them, right? There's 3 options for the first letter, 2 options for the second, and 1 for the third. So if we write them all out, I tend to do this systematically. So I'm like going to start with A, B, C, and then like I'll keep A first. So what's the other permutation that starts with A? C, B. Yep. Okay, and then maybe I'll start with B. So I could do B, A, C. And then what's the other one that starts with B? B, C, A. And then I could do the ones that start with C. So C, A, B, and then C, B, A. And again, this should not be surprising because we know from writing spaces, right? 3 options for the first letter, 2 options for the second, 1 for the third. 3 times 2 times 1 is 6. Okay? So there's 6 permutations, I should add an S there, of those 3 letters. Okay? How many ways can I group those letters? If I'm making a group of the letters A, B, C, how many ways can I do it? You got to have a group with the letters A, B, and C in it. How many groups could you make that have those 3 letters in them? There'd be 6 different groups. What do you think? Yep. Does it have to be ordered? What do you guys think? If you're just making a group, let's say I made you into a group for a group project. Does it matter whose name comes first on the group project? No. Okay, so you're just making a group of the 3 letters. The 3 letters have to go in the group. How many ways could you do it? Yeah. 1 group. There's only one group of 3 letters that has the letters A, B, and C in it. That's it. Yeah, there's only one group with A, B, and C in it. Okay, so the combination right, this is 6. There's just one. Because I can reorder these however I want. It's still the same 3 letters that go into that group. Okay, and that's because, again, you jumble them all up, still the same 3 letters, right? The order of the letters doesn't matter. Okay, so we're going to have way more permutations, way more arrangements of objects than groupings of objects. Now, not super efficient to have to write them all out. It wasn't efficient to have to write arrangements of, permutations of objects out. It's not super efficient to have to write groupings of objects out as well. But just to kind of explore how this all works, okay, we're just going to do that once. So I don't have very much room here, so I'm just going to go on to another page. But hopefully you guys have written a little bit smaller than I have. Okay. Let's make up an example. So let's say there's 4 people. Okay, give me 4 names. Joe. Okay. So there's 4 people. And just, if you can help me out a little bit, let's try, if we can, to stick with 4 names that start with different letters so that I can abbreviate. Joe. Who else? Axel? Okay, like A-X-E-L?
No, A-X.
L-E?
No, A-X-L.
A-X-L? Is that a name, A-X-L? Okay, like that? Okay, sure, let's go with it. Okay, what's another one? Yeah? Bob. Nobody's saying their own name. Wow. In my morning class, we had some narcissists. Okay, who else? Jen? No, that's a J. That's a J. Like Jennifer Goodwin? G-E-N-N? Yes? Ginny, okay. Like G-I-N-N? Or G-E-N-N? Like gin, like the drink? No. Okay, fine. Like generation?
No, like Geneva.
Okay, like Geneva. Okay, I can buy into that. Okay. So I'm going to ask you guys 2 questions. Question 1. First question is, how many ways could you form a 2-person lineup out of these 4 people? Okay. All right, what do you think? Do you think order is important here? Let's start with that. No? Really? If you're at the grocery store, do you want to be first in line or second in line? Preferably first, yeah. If it doesn't matter to you, you are seriously laid back. You're not like me, right? Or like if you think about this, right? I've got little kids. Trust me, first and second matters a lot to them. Okay, so yes, anytime you have a lineup, order is important. So that is something that you need to know, okay? Because I know for you guys, sometimes it's like, well, it doesn't really make a difference. I don't care, like you can go ahead of me. But in the context of a counting methods question, if you are forming a line, order is important, okay? This is a permutation question, okay? So yes, order is important. So if this is a permutation question, order is important because there's a line, there's a first person and a second person. That's a different lineup than if you switched and someone else was going first and you're going second, okay? How would you approach this? How would you start to solve it? What do we do? What do we do? How many people are going into the line? 2. Okay, so what should we do? How should we set it up? 2 spots, yes. Okay. How many options are there for the first spot? 4, because there's 4 people right now, right? Okay, what about the second spot? 3. Okay, so how many ways can we form a 2-person line? 12. Here we go. Okay, so that's the first question. Second question. How many 2-person groups can be made? Okay. Is order important here? No. Right? Because if 2 people in this class work on a group project together, it's not a different group project if you switch the order of their names in the top left corner of the project. Okay? So it doesn't matter the order of the group. It's the same, still the same 2 people in that group. Okay, so let's actually write out the groupings here. Let's start with Joe. Who could we group Joe with? Who could we group him with? Yeah, anyone. So let's say we make a group of Joe and Axel. We could also do Joe and Bob. Or we could do Joe and Jen, or Geneva. Okay, all right, so those are the groupings that we could make with Joe. Let's move on to Axel. Who could we group Axel with? Joe, Bob, and Jen. Okay, should I write Axel and Joe down? Should I write AJ down? What do you think? No, why not? You already have the group of Joe and Axel down. It's the same group. If I write JA or AJ, it's still the same 2 people. So I'm not going to write AJ down. I've already got that group down. Okay, but what other groups could I make with Axel? AB, Axel and Bob. Okay, or what else? AG, Axel and Geneva. Okay, so I've exhausted the possible groups with Axel. Okay, let's move on to Bob. So I'm trying to do this systematically, right? I started with Joe. I figured out all of the possible groups with Joe. Then I moved out onto Axel, and I figured out all the possible groups with Axel. Now I'm moving on to Bob. Okay, what are the groups that I could make with Bob that haven't been made already? Yep. Yes, Bob and Jen. Okay. Okay. Anything else? Do I need to move on to Jen? No. Why not? Yeah, Jen's already been used in with all the other people, right? So I've already got the group of Jen and Bob, and Jen and Axel, and Jen and Joe. So I've got everything down, okay? How many groups are there? 6, yes. Okay, and in fact, this is exactly half the number of lineups, and that's because I don't have to account for reversing the people, right? If I'm thinking about permutations, well then JA is different from AJ. So I could actually double these by reversing the order of the people. Okay, so that's why these get halved. Okay, now to actually figure out why though, because this is a really simple example. We're looking at really, really small numbers here. And we're gonna start to look at numbers that are much bigger than this. And so what we really wanna do is generalize so that we can apply what we've kind of picked up here to much bigger problems. Is we're actually gonna go back to the permutation formula and the combination formula. And I know that I mentioned that the permutation formula is not very handy, and it's not. The combination formula, though, is very handy. And it's useful to look at the permutation formula to be able to compare to the combination formula so that we can see why this happens. Okay? So when we look at question 1, this is a permutation. How many objects did we start out with? How many objects were there in the problem? 4. How many of them did we arrange? How many of them went into the lineup? Question 1, how many people went into the lineup? 2. So we started with 4. We arranged, or another word for arrange is permuted 2 of them. Okay, so we had 4 objects, and we permuted 2. Okay, this is 4p2. Okay, and again, I would never actually solve this problem this way, but our goal here is not to try and solve a permutation problem using this formula. It's to be able to see why the combinations get reduced as compared to the permutations. Okay, now the NPR formula, and this is on your formula sheet, and it's also a button on your calculator, is n factorial over n minus r factorial. Okay, so if we look at this specific example with numbers, what is our n? 4. So 4 factorial over, what's n minus r? 4 minus 2, and 4 minus 2 is 2. So 2 factorial. Okay, now of course you could do this on a calculator, but just so that we can see what's mathematically going on. Okay, so we've got 4 times 3 times 2 times 1 over 2 times 1, right? And then the 2 times 1's cancel, and we end up with the 4 times 3, which is what we had in our spaces, which is 12. Okay, so again, not efficient, but that's not our goal here. Okay. In the second question, okay, we started with how many objects? 4. And we grouped or combined two. Okay. Now, we could write this as 4C2. And the way that you would say that out loud is 4 choose 2. We start with 4 objects and we're choosing 2 of them. Okay? Now, the formula for this, NCR, it's like NPR, but there's an extra factorial in the denominator. So it's still n factorial over n minus r factorial, but there's also nr factorial in the denominator. Okay, so it's n factorial over r factorial times n minus r factorial. So we've got this extra r factorial in the denominator. Okay, now if we look at what this would look like, in this case, in the numerator, our n, again, is still 4, so 4 factorial over, r is 2, so 2 factorial, and then what's n minus r? 4 minus 2 is 2. 2 factorial. Okay. So if we expand that out a little bit, we're going to get 4 times 3 times 2 times 1 over 2 times 1 times 2 times 1. Okay. Now, the 2 times 1, just like in the permutation, still cancels out. But what's happening with this extra r factorial, this extra 2 times 1, okay, is this is dividing out the number of ways that I would have been able to arrange those 2 people if it had been a permutation instead of a combination, right? If we're looking at the group of 2 people, and it's a group, okay, order doesn't matter. Okay, so what I have to do to make it into a group is I have to take the number of ways that I could arrange it if it was a permutation, which is 4 times 3, and divide out the number of ways that I could arrange it, right? The 2 people, the 2 times 1. And that reduces the number of permutations into the grouping, right? So that instead of having 12, I have 6 now, because now order doesn't matter. So this extra division is basically dividing out the fact that we don't need to account for ordering anymore. Okay, and so that's why we have this extra factorial in the denominator. Okay, now 2 times 1 is what? 2. So 4 over 2 is 2. So we end up with 2 times 3, which is 6. Okay? Now, you don't use the NPR formula very much at all, but this one we do use. Okay? Because a lot of the time with combinations, we don't have these restriction things, or the restriction things are things that we can kind of account for at the beginning and then still apply this formula after. Okay, so this is something that we're going to use a lot. And so you do need to know where to locate that on your calculator. Now, I can show you where the buttons are if you want, but you guys can also find them in the same place where you find the factorial button and the NPR button. Okay, so on the TIs, right, this NCR button, firstly you have to enter in the number first. So let's say you're doing 4 choose 2. Okay, if you have a TI, you would enter the number 4 first. Okay, so maybe do this along with me, because this is something we're going to do a lot of. Okay, and then which button did you have to press to get like the factorial button? Ah, that didn't sound good. The math button, that's right. So you got to hit the math button, which is right under the second one, like it's 2 ones under the second one. And then what do you have to do? Right, so go arrow, arrow to probability. Okay, and then can you guys see where NCR is? Which one is it? 3, right. So you're just going to hit that, number 3, and then you can hit 2, which is your R value, right? So then you hit 2. And then enter. And you get 6. Okay? Who has a Casio? Did you figure it out? Yeah, you're good? Okay, cool. Okay. Let's get into some problems. I think you're actually going to like these. I think you're going to find them simple, not simpler, more simple than permutations. It's a good thing I'm not an English teacher. Can I tell you guys a story? So my first year teaching, they give the new teachers like a really bad load, right? Because you're getting like whatever job you can take. So I taught at 2 different schools, and because in Vancouver, it's not semestered. So all courses go the whole year, but they're on a day 1, day 2 system. So on day 1s, I taught at one school, and on day 2s, I taught at the other school, which was actually pretty good because I could wear the same thing 2 days in a row. But one of my courses was a grade 9 modified English course. Yeah, anyway. So I bumped into, that year, my high school English teacher, who was retired at that point. His name was Mr. Dinos. And I said, hey, Mr. Dinos, I'm teaching math. And I said, and by the way, I'm teaching an English course too. And he said, oh dear, that's not good. And I didn't think that was very nice. But anyway, my English skills did improve between high school and starting my teaching career. So yeah, it was good. Okay, a committee of 4 people is to be formed from a group of 9. How many possible committees can be formed? Oh, you know what we forgot to discuss? I got ahead of myself. We didn't actually discuss situations that are combinations versus permutations. Should we do that first? Yeah, let's do that. Okay, I got all excited about the formula and stuff. Okay, let's do that up here. Before we get into some problems, let's actually talk about how do you tell what's a permutation versus a combination, okay? Well, the more you do these problems, the more you're going to start to recognize it. But the first thing that you want to ask yourself to be able to tell if something's a permutation and a combination is this: does order matter? Okay. Now, it's a little bit tricky though, because as you guys just realized, when I asked you, does it matter if you're first or second in line? It may not matter to you, right? But it may matter to some people. So you have to think about, would the lineup be a different lineup if someone else is first in line versus someone second in line, right? So that's one thing to think about. But another thing that is a sort of telltale sign is this. If you can think of the objects going to different places, okay? So for example, with the fruit platter, right? You've got your strawberries going on the far right, and then your cantaloupe, and then your pineapple, and then you've got your kiwi, and then you've got your blueberries, and then you've got your grapes. They're all going to different places on the tray. That's a permutation. When things are going to different places. And the places, sort of metaphorically, the way that we represent those are by spaces. That's a permutation. Okay, so perm versus com, maybe. And we'll talk more about this tomorrow, but is order important? Okay, so that's something you want to do. The objects go to different places? Okay. Now to contrast that, right? If they're not going to different places, they're all going into the same pot. So sticking with the food example, the fruit salad, they're all going into the same bowl, right? You're making a smoothie, you put them all into the same blender, you blend them up. Okay? If you are putting stuff into a bag and then you're shaking up the bag, they're all in the same bag. They're not going into different bags. That is a combination. Okay? Anytime you are ordering letters, the letters have to go to different positions. Okay, so if the letters aren't just going into a bag, but they're specifically going in a specific order, that's going to be a permutation. Okay, or anytime you have to do a passcode, does order matter when you're entering in digits or characters for a passcode? Does it matter? Do you have to get the right digit first? Yeah, order matters there. Okay. All right, what about if you have like are any of you guys in clubs or anything like that? Yeah? Do the clubs have like a president, or are there any specific positions on the clubs? No? We don't really have a student council here, do we? Oh, we do? Yeah? Leadership, right?
There's leadership and then there's principal advisory council.
Right, principal advisory council and leadership, yeah. When I was in high school, we used to have a student council that would be elected, and there was like a president and a vice president, and there were a bunch of other positions. And we don't really have that here. We don't have like an elected student body, right?
Is there a reason why we don't have
I don't know, but let's talk about that later, okay? But back to what I was speaking about. Okay, so have any of you guys participated in leadership or anything like that? Okay, a couple of you have. And can you guys all imagine what a student council looks like, where you have elected positions? Yeah? Okay, one of those is a permutation. Okay. Time to add in some restrictions. Okay, so here's an example. A school committee of 5 is to be formed from 12 students. How many committees can be formed if John must be on the committee? Okay, so John's got to be on the committee. Well, if John's got to be on the committee, how many people do we actually have to choose to be on this committee? 4, yeah, because John's going to take up one of the positions, right? So if John's going to be on the committee, then we need 4 more people. Okay? So we're only going to choose 4. Now, from 12 students, John's already chosen. How many people are left? 11. Yeah, so if John's chosen, 11 people left after John is chosen. Okay, so this, instead of 12 choose 5, becomes 11 choose 4. Okay, now the restrictions are not always as simple as that though. For example, a volleyball team has 6 players. How many different teams can be formed from 15 players if Tracy is injured and cannot play on the team? Well, if Tracy is injured, she's off the roster. She's on what we call the injured reserve list. So how many people do we have to choose from? We've got 14 players to choose from, right? Because Tracy's out, right? So this now becomes 14, right? Tracy's out. How many do we need to choose? 6. Because we got to have 6 players on the team. All right. Okay, so I want you guys to try these 2. And then we're going to get into situations where we have cases, or perhaps we have things like multiple restrictions, that sort of thing. Okay, so number 2. Group of 15 friends are going on a road trip. How many ways can one car that has 5 seats be loaded if Frank must drive and his girlfriend Harriet must be with him? Okay, well, if Frank has to drive and his girlfriend has to go with him, how many spots are going to be left? 3. There's only 3 spots left. If those 2 people are going to be in one car, how many friends are left? 13. Yeah. So we take those 2 people out of the total. So there's only now 13 friends. So we've got Harriet and Frank. So this becomes 13. But now they take up 2 spots in the car. So this becomes 3. Okay? Okay. Cases. So one thing I just want to talk about with cases before we begin is a couple of words to look out for. What are some of the words that we have to look out for cases? And, yep. What else? Yep. Or. Anything else? At least. Anything else? At most. Okay, now I've kind of divided these up into two sections for a reason. Why do you think I did that? I put and on one side, and then at most, at least an or on the other side. That wasn't random. Yeah.
Because with cases, depending on the word, you might have to multiply, add, or subtract the cases.
Close, yeah. So depending on the wording, with these three, what do I need to do? With case 1, case 2, case 3. With the number of either combinations or permutations. If it's case 1 or case 2. Yep. What do I need to do with the total number? Yeah. Add. If it's case 1 and case 2, what do I need to do? Multiply. Okay, so with that, a committee of 3 boys and 5 girls is to be formed from a group of 10 boys and 11 girls. How many committees are possible? Okay, so firstly, which of these situations do you think it is? Is it the and or is it the or? It's the and, yes. No, that's the wrong thing to, sorry. There we go, okay. 3 boys and 5 girls. So I've got to figure out how many different committees can I make with 3 boys and how many different committees can I make with 5 girls, and then I multiply them together. Okay, all right, well, how many different committees can I make with 3 boys? I've got 10 boys to choose from. 10 boys to choose from, I need 3 of them. I don't want a number, I want to know how would you do it? Use, yep, 10 choose 3, yeah. So this piece becomes 10C3 because you've got 10 boys to choose from and you need to choose 3. What about this piece, the 5 girls? Yep. 11 choose 5, yes. Because you've got 11 girls to choose from and you need to choose 5 of them. What do you need to do with these 2 values? Multiply. That's it. The and means you multiply. Okay, now we'll just do this one as well. Let me just, hold on. Yeah. Let's do this number 1 together as well. And then I'll get you guys to do 2 and 3 by yourself. Okay, and then if we need to, we can do some of them together. Okay, 15 dancers are auditioning for Cirque du Soleil. How many 4 or 5 dance troupes are possible? Okay, well, which situation are we in here? The add or the multiply? Add, yes. Okay, so we got to figure out how many 4 group dance, sorry, how many 4 person dance troupes are possible? How many 5 dance troupe people are, I don't know what I'm saying here. How many 5 dance troupes are possible? 5 person dance troupe, that's better. And then we add those together. right? So this is like case 1 or case 2. This is like the 4-person. This is the 5-person. Okay, so we're doing the 4-person. What would that be? How many people do we have to choose from? 15. How many are we choosing? Choose 4. What about the 5-person? 15 choose 5. What do we do with these two values? Add them. Okay. All right, I want you guys to try and complete questions 2 and 3. And then if we need to, we can talk about some of these. Okay, we'll briefly talk about number 3. Okay, so I think what's kind of tripping people up is the at least 7 toppings. Okay, so you've got an ice cream bar has 9 different toppings that are available. How many different sundaes can you make with at least 7 toppings? Got to have at least 7 toppings. How many toppings could you have? You got to have at least 7. What works here? What works for at least 7? Yeah?
7, 8, or 9.
7. You could have 7 toppings. That works for at least 7. So case 1 is 7 toppings. Or what else is at least 7? 8. Or case 2 is 8. That works for at least 7. Or what else works for at least 7? 9. Or case 3, 9. Okay, and then you can't go higher than that because there's only 9 toppings in total, right? So this guy, if there's 9 toppings to choose from and you're choosing 7 of them, is going to be 9 choose 7. This one's 9 choose 8. This one's 9 choose 9. What are we doing with these 3 values? Adding them. Okay, so in a moment, we're going to continue talking about combinations and permutations. But before we do that, I want to ask you guys a question. And I've asked this question many times, and I've gotten many answers. And I've asked this of math teachers. I've texted it out to the math team. I've texted it out to the math department at other schools. I've texted it to my mother, who's a math teacher. I've texted it to my husband, who likes ice cream. I'm going to ask you guys. This is your homework, by the way. Page 118, number 5 to 8, 10, 12 to 19. It's on the board here, too. There's one ice cream cone. There's the second ice cream cone. How many people think that these are different? How many people think they're the same? You got to vote. Come on. I'm telling you, it's already ambiguous because I've gotten different answers. How many people think they're the same? Put your hands up. How many people think they're different? So, okay, according to the According to this unit, the answer is it depends on how the question is worded. If the question is worded such that you are choosing 2 scoops and you're choosing a first scoop and then you're choosing a second scoop to go on top, that would be a permutation. And if the question is worded, you're just choosing 2 scoops of ice cream to go onto a cone, that's a combination. Because in the wording of the question, there's no order implied in the wording. In my opinion, how many people thought that these were different? I think they're different because I think that like the flavor that you eat the cone with, like that's a flavor experience, don't you think? Yeah, like if you're putting it into a cup.
The question says Sunday.
No, I know. I'm not talking about this question with the sundae. No. If you lick it, you lick the top one first. And you push, I'm sorry, you're licking it into the cone. You push it into the cone. There's no way. If you have this one, this first one, you can't put the chocolate ice cream into the cone. Like maybe a little bit. There's no way of doing it. If it was non-pandemic, maybe I would.
Are you saying that if you eat fast enough, it's the same thing?
All right, all right. All right. Let's rein it in. So we're going to start this lesson and we'll finish it tomorrow after the quiz. Okay? And this lesson, there's nothing new in this lesson. This lesson is about diagnosing questions. Okay? That's what this lesson's about, right? Let's take a question and try and pick it apart. Are we dealing, firstly, are we dealing with a permutation or are we dealing with a combination? If we are dealing with a permutation, well, what type of problem is it? Is it one where we have to set up spaces? Are there restrictions? Is it one where we have a group within a group? Is it one where we have identical objects? Okay, so we're going to do some diagnostics here. Okay, this is what we're going to do in this lesson. But in terms of, are we going to look at new types of problems? No. All right, so we've already kind of talked about the definitions of these 2 words today. So I'm going to get you to help me out with this. Permutation. What's a permutation? What's that? It's a fruit platter. Don't write that on your diploma exam, please. Yeah. It's something where order matters, yes. What are we doing, like what are we doing to objects? Yep. Yeah, we're putting them in places, we're arranging them, okay? So it's an arrangement of objects. Where order is important. Okay? Combination. Yep. Yes, so instead of the word arrangement, yep, what would you use instead? Yeah, grouping. Yeah, a grouping of objects where order is not important. Okay, so things to look out for. And actually, we just discussed this a couple minutes ago. In a permutation, objects go to a specific place. Or space, right? We use spaces to represent these places. Okay? With a combination, all of the objects are going to the same place. So all objects go to maybe I should say instead of a specific place, specific places or spaces. That's a better way of putting it. Okay? In a combination, all of the objects are going to one place or one bowl or one bag. Okay? All objects go to the same place. Right? So some examples of permutations. Lineups. What else? I put that one down first because I know that that one can seem arbitrary because sometimes to us, we don't care where we are in line. But it is something that you do need to know. If you're in a lineup, order does matter. Okay? What else isn't a permutation? Yeah?
What about like those things like when awards are given, like first place?
Yes. Awards or coming in a race, right? A competition or a race. Races, so like first, second, third. Good. Okay, what else? Think about your lockers. Or maybe using an ATM. Combinations, passcodes. Now, combinations is kind of a tricky word, but a locker combo. Or a passcode, right? A license plate or phone number would be along the same lines, right? The order that you put those numbers in is important. Okay, these are all examples of permutations. Okay, a committee with positions. Committee or team with positions specified. Okay? If positions are not specified in the question, though, don't make assumptions. Okay? Combination. What are some examples of combinations? A grouping where order does not matter. Fruit salad, yeah, okay. So fruit salad maybe, right? Okay. What else? Maybe go back to the examples that we just did and look at some of those. Different kinds of salad. Well, unless you're talking about the layered salad. Have you guys seen the layered salad? That's a permutation. All right, what are some other examples of combinations?
Who would you like to call?
Combination examples. Shh. Yep. Well, I don't know. Like, this is another ice cream thing. I kind of think the order does matter on a sandwich. I feel bad for whoever's watching the YouTube video right now. I don't want the mayo right on the bread because then it gets soggy, like especially if you're making it the night before. No, actually, that's a good point. I don't like mayo. And also, anyway, okay, guys, in all seriousness though, go on to the previous page, look at some examples of combinations. What's that? What are some other examples of combinations? Shh. Other examples of combinations. Yep. Shh. Yes. Teams, committees, without positions. Yep. Sure. Okay. Students making a group for a project, right? In a group for a school project. All right, so what we're going to do now is look at a couple of scenarios together, and this will be kind of the end of our class today, and just decide whether these are permutations or combinations, okay? There are 8 horses in a race. What is the number of ways that 3 horses can be selected to place in the top 3? Do you think that's a permutation or a combination? Compare it to the next one. There are 8 horses in a race. What is the number of ways that horses will place first, second, and third?
So the first one is a combination.
Yeah, this is the first one's a combination because if you're just looking at the group of the top 3, it doesn't matter what order they're in. It's still the same group. Whereas if you're looking at first, second, third, now you're looking at order of first, second, third. Okay, so this is a combination. This is a permutation. Okay, an ice cream parlor has 20 different flavors of ice cream. Oh. A person selects 2 flavors of ice cream. How many ways can a person order this ice cream cone? According to the way that this question has been worded, what is this? It's a combination. Yeah. Because it doesn't say that they're selecting one first and then selecting another to go on top. So this is a combination. Okay. How many ways can a president, secretary, and treasurer be chosen from a group of 30? Permutation. How come? Positions. Yeah. And then finally, and this is where we'll leave it today, how many teams of 5 can be chosen from a group of 30? Combination. There you go. All right, guys, I'll see you guys tomorrow. I have a tutorial after school today, another one tomorrow morning.